Hi, good morning or good afternoon. Welcome to LigoWave's webinar on the NFT 2AC series of access points. All right, we're going to go ahead and get started. Today's webinar is about the Infinity series and specifically the NFT 2AC. My name is Jason Hintersteiner. I am the new Director of Product Development here at LigoWave, and I will be walking you through the key features of the NFT 2AC access point. So if I can advance the slide. So what we're going to talk about today is a little bit of an overview of LigoWave and our value proposition. And then I will talk a little bit about our Infinity AP platform and then do a deeper dive into the NFT 2AC in detail. I'll give you a quick coming soon to excite you about some product that is coming to this platform in the next couple of months, and then we'll open it up for Q&A. So LigoWave was founded in 2007. We are a global company, but we are actually based and headquartered here in the United States in Canton, Georgia, which is a suburb of Atlanta. We sell products in over 100 countries. We do our product engineering and development in Europe. We do our manufacturing in China, and of course, we do our selling worldwide. And our customer support for US customers is based here in the US. So you have local customer support during business hours. We do have 24/7 customer support, and off hours it rolls off to some of our other divisions in Europe and in Asia. But if you call during business hours, you will speak to a human being here in the US. So why LigoWave? How we operate is a little bit different than some other companies in this space. We do both in-house innovation and in-house production. So we develop our own hardware and software. The AP hardware is designed in-house. We're not copying APs from reference designs from other manufacturers. We also use a proprietary point-to-point and point-to-multipoint protocol for 30% faster throughput. And if you sign up for next week's webinar on the DLB 515AC, where I'm going to talk quite a bit about our proprietary protocols that we use for doing higher speed point-to-point and point-to-multipoint. We also have in-house production. We have our own factory, our own manufacturing facility where we make our own product that is in Asia. But we are not a contract manufacturer, so we are not building things for other people. Everything that we're building, we are building strictly for ourselves and our customers. That gives us some higher quality control than you would get from just a strict contract manufacturer. It also gives us faster response times and faster flexibility in terms of responding to market demand for particular products. Our value proposition to you comes in 3 points. One is support. We have free pre- and post-sales technical support. As I mentioned, that is US-based. The engineering support is for applications and not just products. So if you come to us with a project, we will support figuring out how to make our product work with you in conjunction with other products as necessary, because we are applications and solutions focused. We are not just trying to sell you more products. We're trying to make sure that you have the right products for your application. So our pre-sales and engineering support is really focused on applications, not just product. In terms of profitability for those distributors on the call, we are very strict on our channel management, and we have very strict MAP enforcement, which means that we're very militant almost about going after MAP violators. We do have a partner program for customers in order to get discounts off of MSRP, and that allows us to offer higher distributor margins than most of our competitors. Finally, for our customers, reliability is something that we take very, very seriously. We do a full inspection in our Canton, Georgia facility prior to product going out to US distribution channels. And so in addition to the quality controls that we have in the factory, we do a secondary check of product when it arrives in our facility in the United States. And we validate firmware, and we validate everything is working properly, and that allows us to achieve a much, much less than 1% defect rate. So our defect rate is very, very small. So when you get product from us and you deploy it out in the field, it's going to work because it's already been tested. So where do we play? We play everywhere for your convenience. So we're in hospitality, we're in assisted living in hospitals, we're in student housing, we're in apartments and condo complexes, we do offices and commercial space, we do education, we do retail, and we do warehouse and industrial environments. So we play in a lot of different verticals. So let's dive a little bit into the Wi-Fi platform with our Infinity APs. The key features are first, how you can control the APs. We have 3 methods of control, which I'll walk through in a little more detail in a few slides. We have standalone, so you can configure the AP by itself and just deploy it by itself. We have on-site controller, which basically is one of the APs acts as a master, and all of the other APs report back to that master. So one of the APs basically acts as a controller. And that's good for kind of mid-sized deployments, up to about 50 APs. And then we have a cloud controller for being able to manage multiple sites and being able to manage very large sites. And you can either use our public cloud, so we maintain a public cloud server, so your APs can report to us, or if you're doing larger deployments and you want to maintain your own cloud server privately in your own development, in your own network operations center, we can give you the software and you can operate the cloud software privately. The APs themselves can operate in what we call bridge mode, and that's basically as an access point. You can also run the AP as a router, you can run it as a repeater, and you can also do mesh. Security, we support full WPA, WPA2, 802.11.I security, personal and enterprise. Everything is configurable on the web. So if you log into the AP, it has a web interface. If you go into the controller, it has a web interface. For SSIDs, we have up to 8 SSIDs per radio. We do support band steering on all of our dual band models. You can set a VLAN per SSID. You can also set bandwidth throttling per user per SSID. So you can limit the amount of traffic each user is consuming, which is very important in certain environments. We also have automatic channel and transmit power control, sometimes known as radio resource management. We have built-in diagnostic tools, such as site surveys, so you can see what else is in the environment, ping, traceroute, and so forth. And you can also set up these APs as a hotspot with a web login. So that's very important for our retail customers, where you can basically configure the AP to act as a hotspot router, and you can actually specify a login page and force people to log in order to access the service. We have 4 main models of APs in this series. There are actually a couple more, but these are the 4 kind of key models. We have a single stream 802.11n 2.4, a dual stream 2x2, that's the NFT2AC, which is what we're going to dive into next. We also have a 3-stream version of that AP. And we have an outdoor version of the NFT2AC, which is in an IP67 housing with external antennas. So I'm going to dive now into the NFT2AC on the specifications for that, and you'll see that the specifications are pretty standard for an 802.11ac dual band 2-stream AP. One of the unique things that we have in LigoWave that other customers do not is that all of our indoor APs have these 3 LAN ports on the bottom, and you can control the VLAN, the incoming VLAN per port, and this is very important in hospitality environments and in some other environments where you can hook up this AP and you can wire in, for example, the IP television, or you can wire in the minibar fridge, and they can be on their own separate VLANs, and they can wire into the AP into the room without the need for separately deploying a switch. So we have a built-in switch into each AP, and you can control the VLAN through the controller or through the AP itself. That's on the secondary and tertiary ports. So very, very useful for certain environments. In terms of mounting, we have a lot of different mounting options. Most of the mounting is integrated, as you can see here on the left. So if you look at the back of the AP, you can see we have T-rail mounts that are built in to do suspended ceilings. We have the little circular mounts that you can use to attach it to a pole, with for example, cable ties. You can also do just put screws in the wall or the ceiling and mount it that way. We're also coming out with a specifically designed wall mount that snaps onto the back of the AP that's designed to fit over a standard junction box. And it can fit over either a single junction box or a dual junction box. And this is also important for hospitality and other customers such as student housing, where they have wiring into each unit and they want to mount an AP there. We can use the existing wiring, and this mounting plate will allow you to basically just attach the AP directly to the existing box on the wall, and it snaps right in. So I talked a little bit about earlier about how the APs are configured. There are three basic ways that you can configure the AP and control it. So the first is kind of the standalone model that has been common to AP since the beginning of Wi-Fi. You can configure the AP individually. There's obviously no centralized controller management, and this is suitable for small networks. And by small networks, I mean 1 or 2 or maybe 3 access points. Because as you scale up in the number of access points you have to try to configure standalone AP, all of those standalone is very difficult from a management and monitoring perspective, because in order to see what's going on, I got to log into each AP. And if I want to make a change, let's say I want to change an SSID or change a passphrase, I got to log into each AP to do that. So for very simple networks where you got 1 or 2 access points, standalone is fine. As you start getting into larger networks, then you want to have some type of control. And you can either have local control, where one of the APs acts as the master controller. So the AP itself takes on the control function. And then that configuration is then replicated onto all of the other APs on the network, and all of the other APs on the network provide back their statistics to the master AP. When you want to control that network, all you need to do is log into the master AP, and you can see all of the APs on the network. If you need to make changes to specific access points on the network, you do that through the master, but the master AP serves as the controller for the network. However, you don't need a separate appliance. It's all done from the AP. This type of deployment scenario is suitable for small to medium-sized deployments, so up to about 50 access points we can control in this manner. If you have larger deployments, or if you have multiple sites that you want to control, then we encourage you to use our cloud controller, where the APs, instead of talking to a local controller, are actually talking out over the internet to a cloud server. They get their configuration from the cloud server, and they report all of their statistics to the cloud server. And then you, as the network operator, just have to look at a single pane of glass. You look at the centralized dashboard, and you can see what's happening across multiple networks. We do have both public and private versions of this. So the public server is available at controller.ligowave.com. It is free for up to 50 access points, so you can basically kick the tires with 1 or 2 networks. And that, if you want to scale above 50 APs, we do have a service charge there, and it's mainly to cover our hosting costs. For government groups and for other groups that want to keep their stuff internal, we also offer the software for free as a private virtual machine. So if you want to run the machine in your own data center and monitor it from your own NOC, we'll give you the virtual machine. You can load it up in your data center, and then you can have all of your APs talk to your private cloud server, and then you have complete control over that. Again, quite ideal for monitoring large networks, and ideal for monitoring multiple remote locations. So this is what controller.ligowave.com looks like when you log on to controller.ligowave.com. You'll get a screen that looks like that. You can log in or sign up for a free account. Again, the benefits of the controller: you have centralized configuration. So all of the managed APs receive their configuration from the master AP or the cloud. But you still have the ability to set individual parameter configuration per device. So for example, I can set channel, I can set transmit power, I can, if I need an additional SSID to be on one particular access point, I can set that. I can set that as an individualized parameter for that one AP from the controller. So I never actually have to touch the AP. The other main benefit is that it gives you centralized maintenance. So I get all of the statistics. I can see who's logged in anywhere on my network. I can see how much bandwidth they're passing. I can see how much bandwidth the APs are consuming. So it vastly simplifies troubleshooting. It allows for an easy setup wizard, and it's very plug and play. So the way that this works is for the public cloud, right? The AP will, when you plug it into the network, it gets a DHCP address, gets out to the internet. We'll try to attempt to connect to our public cloud. If you have registered the AP, you tell it, okay, this is my instance on the public cloud, and you'll see it pop up as an AP on the cloud. And if you attend our webinar in a few weeks on the detailed, when we do a technical deep dive into how you actually configure an NFT2AC, you'll actually see how we associate an NFT2AC to a controller step by step. And that webinar is coming up on June 5th, and you'll all get announcements about that. I also mentioned that you can operate the APs in a few different ways. So the standard way is what we call bridge mode, and this is kind of your typical AP access point mode, where the access point, each access point is wired into an Ethernet switch, and I have a separate wired router to connect all of those APs out to the internet. I can set up the AP as a mini hotspot, so the primary AP acts as a router as well as an access point. If I have other APs, I can wire it in direct. I can either wire it into a switch, or I can wire them directly into the first AP. This is suitable again for small networks of a couple of APs where I want to have a simple login page. And that's very common in like retail, like restaurants and cafes and so forth. Finally, you can actually operate the APs in mesh mode. So if I can't get wiring to, if I can get power, but I can't get data wiring to some locations, then we can operate in mesh mode, where the root, basically the AP is wired into an Ethernet switch, and the nodes are only connected to electrical power, and they do their backhaul wirelessly. Note, if you're using mesh, you are going to compromise both bandwidth performance and client capacity, and that's not just for us, that's true universally across all AP vendors. It is just the nature of how mesh operates. We only recommend using this mode when cabling is absolutely impossible, and when the bandwidth performance requirements for where that remote node is going is not critical. So I need coverage, and as long as the user is getting something decent, I'm fine. But they're not going to be streaming, parallel 4K video off of that node. So I want to show you some examples of some success stories that we had. So the first is a few different resorts in Panama City, Florida. These are franchised resorts. We have over 1,000 NFT2ACs that are installed in guest rooms across 3 different resorts in Panama City, Florida, and you see some pictures here. And you can see the quote from the hotel franchise owner. They wound up replacing one of our competitors, and they got basically same or better performance for a much cheaper price than what the competitor was offering. Here's an example from Asia where we've deployed NFT 3ACs in this case in hospitals. We have over 1,500 currently installed, and this is for China Mobile to do Wi-Fi in hospitals. Coming soon to a distributor near you is going to be the NFT 2AC Blizzard, which is an IP66 rated outdoor AP. It's got the same specs. It's going to be 2 streams. So it's going to have the same specs as the NFT 2AC. The current outdoor model is IP67 and is in a hardened metal case and is rather expensive. This is going to have a smaller form factor and is going to be more cost effective than the current outdoor models. And we're going to have basically two different models of this. There's going to be one with a built-in 90-degree sector antenna, which is what you see here. We're also going to have a version of this that will just have external antenna ports if you want to either use Omni antennas or add some custom antenna from a third-party supplier. And you will be seeing this arriving sometime this summer. So keep an eye out for it. And we'll be doing announcements once this comes out. That's it for the formal portion of the presentation. So if you want to reach us, there's our phone and our email, and I encourage you to follow us on Facebook and Twitter. So at this point, I will be happy to open it up for questions to the audience to see if you have questions on anything that I covered today. So if you do have questions, please put them in the chat window, and I will be monitoring the chat window. Okay, I've got one question that I see here that says, what's the range on the access points? And the answer to that is it depends. So nominally, you'll see that we have an output power of 27 dBm, and that's on the specification here. Sorry, 27 dBm, and we have 3 dBi internal antennas. When you're designing a network, however, you want to make sure that you are designing it for the client devices, because the APs at 27 dBm is kind of screaming. That's really, really loud in RF terminology. An iPhone, by comparison, has an output power of about 10 dBm, which means that it is almost 100, and dBm is a logarithmic scale. So that means it's about 60 to 70 times quieter than the maximum volume of the AP. So if I set my APs to 27 dBm and they're screaming, then I can hear the signal very, very far, probably a good 100 feet away or more. However, my iPhone is whispering in response. So typically when you design these things, and we will have future webinars on how to best practices for design. Typically when you design these things, you're going to typically design for 1,500 to 2,000 square feet. You might get away with a little more if it's a nice open floor plan and you've got kind of simple drywall. You're going to design for less if you're in a concrete building or plaster with wire mesh stucco and that type of thing. And you're going to want to lower the output power to be closer to what the iPhone can do, so that gives the ability for the AP to hear the iPhone. So typically you're going to be placing these things roughly 40 to 50 feet, but it very much depends on the layout of your facility. But that's one of those things that we're happy to work with you on. So if you have specific projects, we're happy to talk with you about, okay, where you should put the APs and how many you need, and whether they should go in rooms, and we'll be happy to work with you on that. I see another question here, map on the outdoor AP in Q3. I know what it is, but I'm not allowed to advertise it yet. The map on our current outdoor AP is on the order of about $200, and I will tell you that it will be less than that. So it will be between $100 and $200 will be mapped on that outdoor AP. I can't actually disclose anything further at this point in time, but when that AP comes out, it'll be in that $100 to $200 range. Okay, we'll leave it open for another minute to see if there are any other questions. Okay, hang on. I think I see another question here. 50 free cloud controller is up for 50 units regardless of the number of networks. Yes, that is true. It is based on the total quantity count of APs. It does not matter. You could literally set up 50 separate networks with one AP each, and it would be free for up to 50 APs. So it doesn't, the number of networks that you have doesn't matter. There are a couple of handouts that have been uploaded for those of you who are still online. We have a description of our partner program. We also have a promotion going on right now, which I forgot to talk about. And I will bring that up here. It is a limited time offer where you can get the AP for $75. So, which is quite discounted from its map price, which is around $100 if I recall correctly. So we're offering quite a deep discount for trying out the NFT 2AC. So, and this promotion runs through the middle of May. So that handout is there. Otherwise, just mention that you saw it on this webinar, and we'll get you that price. If you have, all right, so here's another question. If I have 5 clients and they have 5 APs each, they are all free. Yes, you would set up individualized demo accounts for each client, because I assume you don't want the clients to see each other. And then each of those clients can have up to 50 APs for free. Now, we may be limiting that to a smaller number in the future. There has been some talk about that, but right now it's still 50, and certainly anybody who registered for an account would be grandfathered into that. But yes, so you can access the public cloud controller for free, but you would need to set up separate cloud instances for each client. But yes, they would all be free. Okay, well, we're coming up to the half hour. So thank you very much for your attendance and for paying. If you have any other questions, please feel free to reach out to me. My email is jasonh@ligowave.com, or you can find us on Twitter at LigoWave, or reach out to our support line, all of which I have at the bottom here. So thank you very much for your attention. Have a good rest of the day.